Are electric cars truly clean? And are they really the future? For more than a decade, electric vehicles have been celebrated as the clean, inevitable future of transportation. Silent on the streets, free from tailpipe pollution, and powered by the promise of renewable energy. Governments subsidize them. Automakers race to electrify their lineups, and drivers feel a quiet pride when plugging in instead of filling up. But the reality is more nuanced. Whether an electric car is truly clean depends not only on what powers its wheels, but on what powers the grid and what happens before and after those wheels ever touch the road. Every electric car begins its environmental story long before its first mile. The electricity used to charge an EV can come from very different sources: coal, natural gas, nuclear power, hydroelectric dams, or renewable energy, such as wind and solar. In countries like Norway, where nearly all electricity comes from hydropower, an electric car emits about 1/10 the carbon of a conventional vehicle. In contrast, in regions still dependent on coal, the advantage shrinks dramatically. In short, an EV is only as clean as the grid that charges it. The good news is that many power systems are steadily decarbonizing. Solar and wind energy are now cheaper than ever, and nations from the US to China are investing heavily in renewable capacity. As the grid grows greener, every existing EV automatically becomes cleaner over time, something no gasoline car can ever claim. Beneath the smooth shell of every EV lies a battery pack that is both its strength and its burden. Manufacturing a large lithium-ion battery requires vast amounts of energy and mined materials: lithium from South America, cobalt from the Congo, nickel from Indonesia. These supply chains are carbon-intensive and, in some cases, linked to labor and environmental challenges. This means that, at the moment it rolls out of the factory, an electric car usually carries a higher carbon backpack than a gasoline car. Yet the equation changes once the car starts moving. Because an EV produces no tailpipe emissions, it gradually pays back that carbon debt. Studies suggest that after roughly 20,000 to 30,000 kilometers of driving, an EV overtakes a comparable internal combustion car in total climate performance. And from then on, every kilometer driven is a net gain for the planet. The next frontier is recycling. Emerging closed-loop systems can recover over 90% of battery metals, drastically reducing both emissions and dependence on new mining. Several companies in Europe and Asia are already building large recycling plants, hinting at a more sustainable second life for EV batteries. Pollution doesn't end at the tailpipe. Even a car with zero exhaust can leave an ecological footprint. Battery waste, tire particles, and brake dust all contribute to pollution. Poorly handled end-of-life batteries can leak toxic chemicals into soil and water. Mining regions often face deforestation and water shortages linked to lithium or cobalt extraction. But these are not unsolvable problems. They are governance problems. With stronger environmental standards, ethical sourcing, and efficient recycling infrastructure, the EV supply chain can become far cleaner. The technology itself is not the enemy. It's how humanity manages it that determines whether clean mobility lives up to its name. Are electric cars the only road ahead? Not quite. The future of transportation is unlikely to belong to one single technology. Hydrogen fuel cell vehicles, for example, generate electricity on board and emit only water vapor. They refuel in minutes and can travel long distances, advantages for trucks, buses, and long-haul transport. Yet green hydrogen, produced using renewable electricity, remains expensive, and the infrastructure to store and distribute it is still in its infancy. Another candidate is e-fuel, a synthetic fuel created from captured carbon dioxide and hydrogen. In theory, e-fuels could allow existing engines to run carbon neutrally. In practice, the process is highly energy-intensive and costly. These fuels may find niches in aviation or shipping where batteries are impractical, but they are unlikely to replace EVs for everyday drivers. Meanwhile, battery research is advancing at breathtaking speed. Solid-state batteries promise faster charging, higher safety, and fewer rare metals. Within a decade, tomorrow's EVs could be lighter, cleaner, and cheaper. The clean transport revolution will be decided as much by politics and money as by engineering. Global automakers are committing hundreds of billions of dollars to electric platforms, battery factories, and supply chain security. Governments offer incentives, tax credits, and infrastructure funding to accelerate adoption. This growing industrial ecosystem creates momentum that's hard to reverse. At the same time, diversification continues. Japan and South Korea are betting on hydrogen. Germany and Chile are investing in e-fuels. China dominates the EV and battery market, but is also exploring solid-state technology. The future of mobility won't be a single straight road. It will be a network of evolving pathways, each optimized for a different purpose. So, are electric cars truly clean? In most cases, yes, and increasingly so as grids and factories decarbonize. Are they the future? Probably, though not the only one. The electric car is the front-runner in our race towards lower emissions, but the ultimate goal isn't to crown one technology as king. It's to build a transport system that matches each need: batteries for daily travel, hydrogen for heavy transport, and synthetic fuels for the skies and seas, all moving in the same direction, towards a cleaner, fairer, and more sustainable planet.